In this video, we're going to talk about how to evaluate a limit from a graph. So first, let's just remember a couple of things. So first, if we're finding a limit, that means we have this LIM notation. Our x value should be getting very close to this value a, but we actually don't care about what happens at a itself. We just want to be close to a. And then our y value should be getting close to this single value b. All right, so in this example, we have a few different ones to look at. So the first one, we have this graph. We're going to find the limit as f of x for f of x when x approaches -2. So our x value that we care about is -2. And figure out what y values are happening there. So what I like to do, especially when I have a screen like this, I look at my x value being -2. And I think about this kind of strip of values where x is -2. And then on that strip, I see where my y values are. And the only place this strip hits my graph is right here. All right. So when my x values are close to -2, the only places my y values are close to 3. All right, so the limit is 3. So even though f of -2 doesn't exist because I have the open circle, the limit is 3. All the y values are near 3. All right, what about as x approaches -4? I do the same thing and go to -4. I kind of think about all the values near -4 where that could hit my graph. In this case, the only time it hits my graph is in this region. And you can see the limit for there is going to be 0. All right, so even though there's not an open circle or something weird happening there, it just turns out to be the same as the function value. That's perfectly fine. All right, but all my y values are close to 0 when my x values are close to -4. And the last one, at 1. Again, I'm going to think about when I get close to 1, where can my y values be? And you see there's 2 different places. I have some y values that are hitting this dot up here, and I have some y values that are hitting this open circle down there. And we've seen a few times now that if you have these 2 different possibilities, these 2 different y values that you're getting close to, that just means we're going to say our limit does not exist. Because some are 6, some are 3, and it doesn't make sense for it to be 2 things at once. All right, another example, just doing the same stuff. First one, we have our limit as x approaches -8. So I'm going to go to x value -8 on my graph and look at all the y values. All right, so the first thing that might happen is you might say, well, I have some y values down here, this open circle, and some y values right there at -3. And you might say that this one does not exist because there's 2 different y values. But again, when we're thinking about a limit, we just care about around the value, not the actual value itself. So this single dot all by itself actually doesn't affect the limit at all. All right, a single dot's not going to change the limit, but a lot of values, a full line will. So we can actually kind of ignore this line at -3, and our limit is just -6. So our y values kind of should be -6. That one dot being separate from everything else doesn't really change what the value should be. The value should be kind of this dot right there at -6. What about as x approaches 6? Again, anytime you can pause the video and try to answer it yourself before I do. At 6, we're going to look here. And these are all the x values around 6. And hopefully you can see that there's some y values here and some y values up there. If we're getting these 2 different y values, that's when we say our limit does not exist. And our last one, x approaches 10. So we're going to focus on our x value 10. And that only has a single place where those x values are hitting my graph. That's right there at 0. So there's one quick note about this last example for x approaches 10. Sometimes students say this does not exist or something because when we're doing these limit problems, we're so used to looking at the open circles to be our answer because those are kind of the questions that pop up on the AP tests and stuff a lot. But limits can be nice too. When you just have a single dot and there's nothing kind of weird happening on your graph, your limit's just whatever you would expect it to be. So here I expect my function at 10 to be 0. The limit's also going to be 0. So it's fine if nothing's weird happening. You don't have an open circle or a jump or anything like that. Or you can also just have a nice limit where it's just exactly what you would expect. All right, so here's a summary of what we just covered. All right, focus on the area around the x value, not the value itself. So when you have something like this, you ignore that one single dot and you just focus on the actual line part of your graph. All right, if there's two different ends to the graph, your limit's not going to exist. All right, when we have this kind of jump situation like that. And it's perfectly fine for the limit just to be the same as the function value. So if I just have a function that looks like this, all right, this could be the limit at that value. All right, it's not always going to be something weird happening. Sometimes it's just the function value. All right, so that's how to evaluate a limit from a graph.